Hello everyone. In this video, we will continue to work with the triangular voltage waveform. In previous video, we have found the equations for this triangular waveform, and we also found the value A0 as a DC component. So let's rewrite our two equations that we found in previous lesson. So we have Vt is equal to 2V max divided by T times T from T within the period of T over 2 and 0. Okay, and the other equation we have is Vt is equal to minus 2V max divided by T times T plus twice the V max, given is between the period of less than or equal to T over 2 and less than or equal to T. So it is a split function, and we are using this values right here as the coordinate, and then we figuring out our two equations. Okay, so this question asks me to find A3. Okay, so before I can find A3, I would like to check what kind of equation that I have to use, what type of formula that I need to use for this A3. So we are going to go to our page 14. Page 14, because we are working with the periodic voltage waveforms in this case. So here is the general solution equation for figuring out my AN. Okay, so take a look at that. We have AN equal to 2 over T, the integral of certain interval, and then there's my function Vt, but I have to multiply that with cos of 2 pi n over T times T as the argument, and dt to integrate my function in terms of T. Okay, so can we write that down then? Okay, we write AN equal to 2 over T, the integral from 0 to T in this case, because we are working with this interval right here. Okay, and then we are writing it as Vt, and we time that with cos of 2 pi n divided by T times T as the argument of cos, and dt to integrate in terms of T. Okay, so now you see that you are having this Vt and this Vt within the two interval, so we have to include all of that, and we also have to figure out A3. So instead of writing the AN, you are writing A3. Okay, so I'm going to write A3 equal to 2 over T. Okay, and in this case, I have two intervals to work with, so I better break it into two integrals. Okay, so I will have 2V max divided by, so let me write the V, so it's clear for everyone that 2V max divided by T times cos of, instead of writing n, I will write 3 in here. So 2 pi n, 2 pi 3 over 3 t, and here is my dt. Okay, and I will add this with the interval of t over 2, 2t, and right here I should have negative 2v max divided by t times t plus 2v max. All of it, I still have to time that with cos of, so I time that with cos of, so I will write it down here, cos of 2 pi n 2 pi 3 divided by t times t and dt. Okay, close this because I still have to multiply that with 2 over t. Okay, So now at this point, I'm going to ask everyone to take a look at this. Okay, take a look at this part. Do you see that you have a binomial multiplied by this cos? So you need to take this whole thing, okay, and you need to multiply this inside the brackets so that you can break this into two integrals to integrate. So I'm going to write it a3 equal to 2 over t The first one is the integral from 0 to t over 2v max over t times cos of 2 pi 3 t dt. So the first one is fine. Now I'm going to multiply, and at the same time as I multiply, I'm going to break this into two integrals as well. So right here I should have the integral from t over 2 to t, and this will be minus 2v max over t times t. And this one, I will multiply this with cos of 2 pi 3 over t dt. Okay, and that is my first one. My second one is the cos multiplied with the 2v max. So I will add this with the integral from t over 2 of t, and this time will be 2v max, and times that with the cos of 2 pi 3 over t dt. Alright, so you see I take this part and I multiply each term inside this bracket. So multiply the first term, I should have negative 2v max over t times t cos of this, multiplied by cos of 2 pi 3t times t times dt, and at the same time I break it into two integrals. Alright, okay. So at this point, to organize our integrand and make sure that we include everything that we need to integrate is quite tedious. So I am going to ask everyone to follow what I've written here. So I will have e3 could be equal to 2 over t multiplied by, and in here I will write three integrals in three different colors. Alright, so I will take this one as integral 1. Okay, so I will put integral 1, and then I add this with integral 2. So let's use this color here. So this is my integral 2. And the last one, I will use purple. Oops, okay. Sorry, alright, check that. And I will use my, so I'm going to add this with integral 3. So this is my integral number 3. And I will integrate this one by one. And after I got the result, I will put it back into this bracket. So let's start with integral number 1. Okay, so I'm going to start with integral number 1. So I'm going to do integral 1. Okay, so integral 1 is equal to the integral from 0 to t over 2 of 2v max divided by t times cos of 2 pi 3 over tt of dt. Okay, So everyone ready? We are going to integrate this. T cos t to t. Okay, so remember in the previous class, we were talking about this, right? We said this is a constant, so it's a lot easier that you bring this across the integral sign first. So I will write 2v max over t integral from 0 to t over 2 of t times cos of 2 pi 3 over t times t dt as the argument for this. Okay, the reason I haven't changed the 2 times the 3 is because I would like everyone to compare with a formula that we have to use next. Okay, so I'm going to ask everyone to go to our formula sheet. Okay, so here our formula sheet. And we are going to go up to this page number 11, and we are going to look at the integral of cos, and what we are going to use is we are going to use number 15. Okay, now you see that integral said that you are having t, you time that with cos, okay, and in this case your n is equal to 3, so here n is equal to 3, and will be equal to this entire thing. And then whenever you see the n, you are going to substitute that with the number 3. Okay, so I'm going to use number 15. Okay, so I'm going to use number 15 on page 11. I just want to write it as a reference for everyone here. Okay, so using number 15, then what I will have is this. Okay, so I will have 2v max over t, and I will time this one with t squared divided by 2 squared pi squared, n squared in this case should be 3 squared. Okay, now inside the bracket I should have cos of 2 pi times 3 over t, and I add that with 2 pi times 3 over t, and then times sine of 3 pi 3 over t times t, and I need to evaluate this at the value from 0 to t over 2. Okay, so this is t over 2. And then I need to close the bracket. Okay, and I have to apply fundamental theorem for this. Okay, apply fundamental theorem for this one. It means I have to have f of t over 2 subtract f of 0. Okay, step by step, we will achieve what we need to achieve. Right here, why don't we simplify something? So that cancel with that 2 cancel with that 2. And on here, I can write it as V max times t divided by 2 pi square and 3 square. Okay, so now let's apply fundamental theorem for this. So wherever you see the t, that's when you substitute in your t over 2. Okay, so I should have this as cos. Okay, so the inside the argument. Now you can go ahead and multiply by this in if you want to. Okay, so what I write 2 pi 3 over t. Now the t, so I substitute with the t over 2. Okay, so this one. Now I will add that with 2 pi 3 over t. Now the t, I will substitute by 2 over 2. I time this with sine. Now inside the argument of this, we have 2 pi 3 over t. Now I substitute the t with t over 2. Okay, so this is only taking care of the very first part of this fundamental theorem. But the second one is now where the t is, I substitute that with a 0. Okay, so now we are subtracting cos of 2 pi 3 over t times 0. And then don't forget that is a subtraction, and all of this are plus, so it turns into a minus. And I will have 2 pi 3 over t times 0 now. Okay, and then I time that with sine of 2 pi 3 over t, and this time is 0, so close the bracket. Now you see what we are going to get. So you see that 2 cancel with that 2, that t cancel with that 3, that t 2, 2, 2, 2. Inside this argument I can cancel that with that with that. Okay, so let's see what we have. So V max times t over 2 pi square 3 square. Okay, inside this bracket I should have, now here I should have cos of 3 pi. Okay, cos of 3 pi. And what I have left, next one is I am going to add that with 3 pi times sine of 3 pi. Okay, so I've done this one, I've done this one. The next step is the cos of 0. Okay, cos of 0 is important. And this is already multiplied by 0 in this case. You see that this is multiplied by 0. So this whole thing is actually becomes 0. Okay, so close the bracket. So I should have V max t over 2 pi square 3 square. And I would like everyone to use your calculator. Okay, use your calculator to figure out cos of 3 pi. So I should have minus 1, cos of 3 pi as minus 1. I should have this equal to 0. Okay, and cos of 0 also equal to 1. So in this case, minus 1. So I will have it left with V max times t 2 pi square 3 square and multiply by minus 2. Okay, so why don't we simplify this part? I can simplify this and that, and I should have a minus 1 left over. So my integral number 1 will be equal to minus V max times t divided by pi square and 3 square. So we circle this. This is our integral 1. Alright, okay. So this is my integral number 1. So all done with negative V max times the period t divided by pi square 3 square. Alright, okay. So now we are going to work with our integral number 2. Okay, so our integral number 2. So I want to rewrite integral number 2. Okay. So here is our integral number 2. Okay, integral number 2 is equal to integral from t over 2 to t, and I should have minus 2v max over t times t, and time cos of 2 pi 3 over t. This is t and dt. Alright, okay. So first of all, bring this across the integral sign. And inside the bracket, I left with this. Alright, okay. So the next step, again, I will also have to apply that formula number 11. Actually, formula number page 11. Formula number 15. Okay. So I will have minus 2v max over t. Okay. Now I'm going to multiply this with t squared, 2 squared, pi squared, and 3 squared. Inside the bracket, I should have cos of 2 pi 3 divided by t times t, close the bracket, add that with 2 pi 3 divided by t times t, and time sine of 2 pi 3 divided by t times t, close the bracket, evaluate from t over 2 to t, and I close the bracket. Alright, okay. So again, I will substitute this in, and I will have f of t over 2 subtract from f of t. Okay. So I should have f of t subtract f of t over 2. So anywhere that you see this t, you are going to substitute in the values. Okay. So let's simplify a few of these. So you can see that cancel that cancel with that. So I should have just minus v max times t divided by 2 times pi squared 3 squared. Okay, so inside this bracket I should have cos of 2 pi 3 times t. Now I will time that with t. Okay, now add that with 2 pi 3 over t. Now time is with t, and then sine of 2 pi 3 times t, time that with t, and I will subtract the cos of 2 pi 3 over t. Now it will be t over 2, subtract again, okay, 2 pi 3 over t, now will be t over 2 times sine of 2 pi 3 over t times t over 2, close the bracket. Okay, so this is equal. So let's see what we can cancel inside our bracket. So you see that can cancel with that can cancel with that, and that can cancel with that. So I can have it as cos of, now I can say 6 pi, okay, I add that with 6 pi times sine of 6 pi, and over here I should have that cancel that cancel that cancel that cancel that, and that cancel that cancel that. Okay, so what do we have left inside this bracket? It's minus cos of 3 pi and minus 3 pi times sine of 3 pi. Okay, we can go ahead and use our calculator. Okay, use your calculator. This will become 1. Okay, add that, this will be a 0, this will become a -1, okay, and this will become a 0. So I should have negative V max sine t, 2 pi square, 3 square, and in here I should have is equal to 2, okay, because I should have 1 plus 1 equal to 2. Now that cancel out what we can cancel, so the 2 can cancel with this. So I end up with negative V max t over pi square, 3 square. So this is my integral number 2. Alright, okay. So I only have 5 minutes left, and I'm wondering if I can finish this off. Okay, because I could only have 30 minutes for each video. So why don't I make a note here? Why don't we continue with video number 3? So my planning was to have only 2 videos for this lesson, but now I'm going to make it into video number 3. So 3 videos, because I really don't want to rush myself. Okay, so I'm going to stop here, and I will continue with video number 3. Alright everyone, thank you.